Hello viewers, this video will be all about macvlans on Docker and containerized systems and what you can do with it, what you have to do to use it, and what the advantages are. Let's talk about the last first. Why would you actually use a macvlan in your Dockerized or containerized environment? Well, first of all, the biggest advantage is that each of your containers gets its individual IP address. You can already imagine addressing a container with its IP address is the coolest thing since sliced bread, because that opens many more advantages, like for example using it in DNS. Think of reverse proxies, think of directly addressing your container with a fully qualified domain name. Cool. And lastly, or one of the other advantages, is that the entire port spectrum from 1 to 65,000 something is available for each of your containers. So you don't have to share your ports with the container host, which gives you a host of advantages, like you don't have to care under which port your Dockerized application runs. Before I tell you how to configure macvlans and what the preliminaries are, I would like to talk about this channel, because if you like what you see, it would be great if you would support this channel, and you can do that by joining Patreon. I offer 3 different memberships, and basically everybody gets to see all my videos, at least one starting from June this year, completely without advertisements. Additionally, I'll be answering all your questions and comments on Patreon with priority. There are 2 additional membership levels, which is Plus and Plus Plus. They give you 10, respectively 25% rebate on my consulting rates. And if you would like to book a consulting session with me, you will find the respective booking link in the video description. Well, of course, there is still the completely free of charge YouTube subscription. And if you're not subscribed yet, it would be great if you could take the time to just quickly click on subscribe. And please also ring the bell, because then you will be notified if there's a new video. Well, now let's start with the first part of this video, which is planning your macvlan and getting to the point where you can then take action. Enjoy. Like everything in life, macvlans start with a good plan. So I suggest taking out a piece of paper and a pencil and writing down a few things. Because you already have an existing LAN configuration with an IP range, which most probably is governed by any DHCP server. So now we have to sit down and make a plan how to, or which part to slice out and remove from this DHCP range in order to prevent double or duplicate IP addresses, which are a complete no-go. So for our planning purposes, let's take one step back and talk about how IPv4 networks are set up, or how they function. They are set up of 4 segments, and each segment is represented by 8 bits. So far, so good. Now we can use each segment and subdivide it using subnet masks, or actually can use subnet masks entirely to subdivide networks. Hence subnet masks. I'm using a piece of software called CyberChef to calculate IP ranges and to demonstrate how this works. Later on, in one of the following videos, I'm going to show you how to install CyberChef. By the way, this is kind of a Swiss Army knife of everything related to IT. We are going to, in one of the later videos, install CyberChef in a container using macvlans, so we are going to eat our own dog food. Anyways, let's now calculate a little bit IP address ranges based on an example. The example will be 192.168.200.0/24. This is a complete network starting from 0 to 256, as you can see down here, addresses. Certain addresses are not, we can't use, and usually this is the 0, which is basically the address of the network. If you were talking to this network, this is the address. And usually behind address number .1, we have our router or our router, respectively our firewall. So these two addresses will be something which we don't want to use in our range. Anyways, let's continue with subnet masks and my example. If you wanted to cut out a piece of two addresses as a subnet, we can use network mask 3.1. And as you can see, it sliced out these two first addresses for us. Now in our mind, if we consider this as our subnet size, we can divide our network range from 0 to 256 into subnets of 2. So basically we have 128 subnets of 2 addresses. Doesn't sound good, doesn't it? So now maybe something bigger might be in order. Let's use subnet mask 30 and we will have 4 available IP addresses in this subnet. Minus the first 2, of course. Now, but this is now to explain the subnet masking. Now, if you wanted to cut out double the number of IP addresses, that would be subnet mask 29, and we get 8 addresses. We go to 28, and we get 16 addresses. 27 gives us 27 gives us 32 addresses. 26, 64 addresses, and 25 gives us 128 addresses. Okay. However, let's stick with something more or less manageable, and 32 addresses seems something which might be helpful. Rather go a little bit bigger, because from my experience, you are going to accumulate containers left, right, and center, and 8 addresses in your subnet will certainly not be sufficient. And once you have to reconfigure that, this is just a nightmare. Just start with something a little bit bigger, at least 16 addresses, better 32. Now, I mentioned earlier that we cannot use the first 2 addresses, and hence we have to basically start our IP range a little bit higher. And if we use a subnet size of 32 addresses, that means we can either start at a 0 and go up to 32, rather 31, as we can see here, 31, 0 to 31. Or we can go one step higher and start at 32 to 63. Or we start at 64, and so on and so on and so on. You get the idea. So let's start at 32 and we get this IP range. If you cannot start at 32, I suggest, or you have to, in this case, start at 64. Not 364, so 64. So you have this IP range from 64 to 95. If that doesn't work for you, you have to start higher and higher and higher, but always in increments of 32. You cannot start in the middle of something. So if, for example, you want to start at 50, this is not possible if you have a subnet size of 32. It always comes in sizes of 8th, okay, hence 8-bit, okay? Because 50 lies right straight in the middle of our subnet range 32 to 63. It's one of these things in life. Okay, let's return to our example and work with this IP address range of 32, subnet mask 27. There is one more little obstacle which we have to tackle, and that is, as I said earlier, our DHCP server. So I'm going to demonstrate this taking the example of my personal router, which is an Ubiquiti edge router. But don't worry, in principle, all these systems work similarly, so you will get the idea where to look, what to do. It's not one-to-one transferable, obviously different products, different interfaces and so on, but you will get the idea of what to do. So let's turn to my Edge router. Here it is. This is its user interface. And I'm going to the services part where I manage my DHCP servers. As an example, I'm going to create a new DHCP server, and I'm going to call it demo. First, we are asked for the actual subnet in which this DHCP server will act, and that is our entire subnetwork. It is 192.168.200.0/24. You get the idea. Now we can tell it the range where it is allowed to issue IP addresses, which is starting, in my case, and this is my suggestion for you, 192.168.200.100, and then we are allowing it to go up to 192.168.200.199. These are exactly 100 IP addresses, which doesn't sound much, particularly if you consider if you have dozens, maybe hundreds even, of IoT devices, intelligent plugs, intelligent light switches, ovens, lawnmowers, sprinklers, whatever. Or even cameras, IP cameras. They also use IP addresses like crazy. So I suggest putting all these devices into different VLANs. For example, create a separate IoT VLAN, create a camera VLAN, and so on and so on. That gives you a plethora of available IP addresses, plus the added security that you can block VLANs from looking at each other. So inherently insecure IoT devices cannot spy into your actual server LAN and find out things which you are doing or storing and transmitting this to entities which are not supposed to get that information. So this is my suggestion. And remember, we're not disabling the other IP addresses in this range. We're just making these available for us to issue them manually and also to make them available in our little macvlan for our different containers. So these addresses are not lost. They're just not available for, I call them random LAN clients, but LAN clients which are using DHCP. All right. So now we have to also enter the address of our router 192.168.200.1. That is basically the exit to the big internets. Now you can still add a little bit more information, which is then basically given to the DHCP clients as configuration items like DNS servers and so on and so on. Okay, now once you've done that, you can click on Save and the whole thing will be applied to your personal environment. One little word of warning though, if you change your DHCP server settings, there will of course still be clients out there using the previous configuration of the DHCP server. This only changes over time. Usually a DHCP lease is valid for 24 hours, and only after that time is over, the DHCP clients will request a new address from the server and then be issued a different one in our allowed range. So just be careful. There will be still other clients zooming around in your network, and there is still a little bit of risk that you are encountering duplicate IP addresses if you go on like this. All right. Just give it some time to settle, 24 hours at the most, and then everything should be clearing out itself. All right. This is the last step in our preliminaries. Now we can have a look at Portainer and how to actually put our macvlan thing into reality. Here we are logged onto Portainer, and if you are not sure what Portainer is, how to install it, and so on and so on, I have a video here for you, which is basically taking you from the installation of Container Manager on Synology to Portainer and a few other tools, and gives you newbie information basically. Don't worry, just have a look at this, come back here, and then continue with Portainer. Container with Portainer. Okay, once you've logged onto Portainer, it should roughly look like what you see here. And by the way, I know there is a new version of Portainer available, but this is a topic for a different video. Now you click on Live Connect, and now you're basically connected to your local container host, which is your Synology. And now we go over to networks. Creating a macvlan is a two-step process. First, we have to create something which is called a configuration. And based on that configuration, we can then, in a second step, create the actual macvlan. I have no idea why it's like that, but this is how this thing rolls, and let's just go with it. Now, click on Add Network. Give this thing a name like macvlan. Let's not talk about online correction here. macvlan config. We just have to use it for our configuration, so give it a name which you can find again. With driver, select macvlan. Automatically, the option configuration is selected, and this is exactly what we need. And in the next step, we have to find out what our parent network card is. That can be a question which is not easy to answer. Many of you will know, yeah, well, it's this and this and that, but let's just take it step by step. And for this purpose, we need a terminal logon to our Docker host or container host, in this case, our Synology. In the video which I mentioned previously, I also explained how to enable SSH on Synology. So if you need to go back, I'm leaving a jump mark in the video description. So just go back to this video and have a look at it. Okay, I am logged on to my Mac in this case, and we need to now SSH into our Synology. Command is SSH. Now comes the name of an admin user. In this case, this is myself. Now comes the @ you know that from emails, and now the IP address of your Synology. Here we are. And now we just need one command, and the command's name is ifconfig. Type it like I do, ifconfig. And now you get a host of information about all kinds of network interfaces which exist. And yeah, they're not necessarily everything which is physically available, but doesn't matter. Now you scroll up and you scroll until you find the IP address of your Synology. In our case, this is this one. Now you look up the name of the network card here to the left, and you're done. Very cool. This can be ETH0, can be ETH1, or sometimes, since you can combine network interfaces on your Synology to a bond, it can also be bond0. You will find it out. Just look for the appropriate IP address here in this list, and you will get the right name. Now we go back to our Portainer, and we enter the name of the network card, ETH1 in this case. Now, from our earlier plannings, we know the IPv4 network configuration. First, the entire subnet in which our container host sits, our Synology in this case, that is 192.168.200.04/24. Your mileage will certainly vary, so please adjust this to the subnet of which you are actually using. Now the gateway address, as I said earlier, where is the exit? That is basically the LAN side of your router, the LAN address of your router, which is in my case 192.168.200.1. Also here you need to adjust it to what you have. Otherwise this will not work. Now, like we calculated earlier with CyberChef, here comes the IP address basically with the range which we want to slice out of our subnet, which is 192.168.200.32/27. If you want to watch the part again where we calculated, just choose the appropriate jump mark from the video description. Now we're finished on this side with our configuration and we can create the network. macvlan config now exists. As I said, we need to take a second step, and that is to create the actual network. Click on Add Network again. Type a name which you can remember and which will ring a bell when you later create containers. Call it macvlan if you like. From the driver side, select macvlan again. Now we go to creation. We create the actual network, and this gives you a drop down. Don't worry, I have two networks available here, one which I'm already using in production, the other one which I use for this video, and the one which we just created. Okay, we can use the letter macvlan-config, and there's nothing else we have to do except for create the network. And if in the previous step, creating the configuration part, you did everything right, the success message will be shown. Now we have a function macvlan. As I just said, we now have a function macvlan. However, there is one little drawback. We cannot communicate between the containers and the container host and vice versa. Don't ask me why. The Docker developers say it's a feature. I beg to differ. Be it as it may, we need a workaround because, frankly, it's a nuisance. There are so many reasons why you might want to consume a container service on your container host, like for example Pi-hole or another DNS service or whatever it may be, or vice versa. And let's just think of a reverse proxy. For this reason, we need a workaround. And the workaround comes in the form of this little script here. And by the way, there is also a download link in the video description. So download it and let's have a look at it, because you have to adjust it to your environment. The first part is just waiting for the Docker service on Synology to come up. If the container service is not called Docker on your side, just you have to adjust this name here. Anyways, let's look at the next few lines. First of all, we are creating a link which is called MVL-BRG, like bridge, on interface ETH0. In this case, I have to adjust it to my configuration, and you will have to do the same. This will be the name of the network card or parent network interface which you used in the macvlan configuration. Remember that and adjust it accordingly. Leave the rest exactly as it is. Now we need to adjust the IP range. In my case, this is 192.168.200.63/32. Now remember this IP address. This is the address which you have to use to address your container host from your container. It's not the normal LAN address, it is this address. If you try to use the normal LAN address, it will not work. You have to use this. For example, if you want to address the DNS service on your Synology from a certain container on your Synology, which you just created in the macvlan, you will have to use this IP address to use the service. Okay, just remember that. And do not double issue that IP address. This is basically reserved. You could, in theory, if we went back to Portainer and create a new macvlan configuration like this, you could exclude this IP address. But this only applies if you let the container host issue IP addresses on its own. Okay, There is a way of excluding it. I'm showing you here. It's a little bit advanced. It's possible, but not really necessary. Anyways, let's go back to our little script, which is here. So this is the address of our container host, respectively of our Synology for our containers. Now, in the next one, we bring this interface up, and now we create in the last line a route into the macvlan itself, also adjusted like I do. This will be the slice of the address range or the IP address range of our macvlan, which we use in our macvlan configuration part. You can, if you like, copy it out from here and paste it in here, whatever strikes your fancy, or you just manually edit this. If you do it exactly as I say, and if you adjust it correctly to your environment, there will be no problems. But how does our Synology now learn how to use this? There's a caveat. We could run this on the command line. That's perfectly okay. However, it will not survive a reboot. So we have to make sure that on every startup of our Synology, this script is being executed. How do we do that? I'll show you. First, we go over to our Synology DSM. We start the control panel, and here we select Task Scheduler. And now you create a new triggered task. User-defined script is the only option. The user under which, give this task a name like macvlan, so that you remember what is there for. Otherwise, you will look through this list and maybe just think, what is this? And I'll delete it and nothing works anymore. Give it a proper name so that you can always identify what it is. The user under which it's going to run has to be root, otherwise it will not work. The event, which is by default boot up, is correct. Always at boot up, this has to run. We have no pre-task, and the enabled check mark should sit as it is. Otherwise, it will not run. Now go over to task settings and position your cursor in this text field under user-defined script. Now hop back to your script, which you just edited. Press Command A or Control A, depending on which platform you are. And now everything is marked. Now you can press Command C or Control C to put everything into the clipboard. Hop back to your Synology and Command V or Control V, paste everything from the clipboard into here. Quickly check again that everything is correct. And I assume it is. Then you can click OK. Read this pop-up or the contents of this pop-up, understand it, and click OK again. Enter the password of the user which you're currently logged on with. And then click on Submit. For the first time, let's run this script manually. In order to do so, just mark it by clicking into the line of that script's name and click on Run. You will be asked whether you really want to run this task, but yeah, we want to do that, and so it's okay to click on OK. And now we want to see whether everything went fine. There is a log, but you only can get to it if you mark this line again. Click on Action and then click on View Result. It should look similar to what I have. If you ran it before, the output will is exactly as shown here. Otherwise, if you run it the first time, it will say created this, created that, and everything's fine. There should not be any error messages. If there are any error messages, you made a mistake in your script, go back and check everything like I said before, the network interface name, the IP address, and the subnet mask. That's it, basically. This concludes the ultimate guide to all kinds of macvlan with Docker and containers. I hope this video was helpful for you, or at least it was entertaining. In both cases, it would be awesome if you would leave me a like, because that positions this video properly in the YouTube algorithm. Additionally, I would like to reiterate what I said earlier about supporting this channel. If you would like to see more like this, it would be awesome if you could subscribe to Patreon. The link is below in the video description. I offer 3 membership levels. All of my Patreon members, of course, can watch my videos completely free of ads, and I answer your questions, respectively your comments, on Patreon with priority. There are 2 additional membership levels, Plus and Plus Plus. These members get 10, respectively 25% rebate on my consulting rates, and if you would like to book a consulting session with me, there is also a booking link in the video description. There is, of course, the completely free of charge YouTube subscription app, and if you have not subscribed yet, it is just the right time to click on the button below, and don't forget to activate the bell, because then you will be notified if I issue a new video. For now, thank you very much for watching, and see you soon. Bye-bye.